Welcome to Session 5. We're going to talk about how to use the QGIS processing toolbox to analyze data in QGreenland. This is one of the most powerful features of QGIS and what makes it a really powerful geospatial data analysis tool. First, let's open the processing toolbox. There's a couple ways to open the processing toolbox. The easiest way is from up here in the Attributes toolbar. There's a button here that has a little gear symbol on it, and if you hover your mouse over that button, you'll see that it says Toolbox. Click on that button, which should open up a new panel for what we call the Processing Toolbox. The Processing Toolbox in QGIS is a collection of built-in tools and functions that allow you to analyze raster layers, vector layers, and other kinds of data layers with the click of a mouse. We're going to work on the Processing Toolbox in QGIS and answer this question. What populated regions in Greenland have more than 5,000 people? We can answer this question pretty easily using one of the two QGreenland datasets and a tool in the QGIS Processing Toolbox. Let's toggle on the dataset. Populated Places is a vector point layer, and it's nested within one of our group layers in the layer panel. You can access it in our Places layer group, and it's nested within the crowdsourced community map. Let's go over the Processing Toolbox. Since this data set is a vector data layer, we're going to be focusing on vector tools. Down at the bottom of the Processing Toolbox is a whole selection of vector tools. Like our layers, they're all organized by topic or by type of analysis that you can do. Open up this collection of vector selection tools. Because we're going to be selecting from the Populated Places vector layer, the places that are considered populated according to our dataset have more than 5,000 people. And the reason that we're able to do that is if we open up the attribute table for the Populated Places layer, you'll see that there's an attribute or column for population. I can query it to find the places that have more than 5,000 people. Over here in our vector selection set of tools in our processing toolbox, we're going to use a tool called Select by Attributes. Double-click on Select by Attribute to open it up. First, let's enter our input layer, which is the Populated Places layer. Because I had it highlighted in my Layers panel, it is already here. If you don't see this layer in your input layer, you can click on it. When you click on the box, you have the option of choosing any of the QGreenland vector layers, and they're all listed in alphabetical order. Scroll down to the P's and choose Populated Places. The next input variable helps us with what we want to find. We want to know the population or populations that are greater than 5,000 people. So I'm going to select the population for our selection attribute. This uses simple operators here, which will help me find places with more than 5,000 people. In the box for value, I'm going to type in 5,000. I'm going to leave this final input here to modify the current selection, as it should say creating a new selection. Double check that your tool is your Select by Attribute tool and that the information that you inputted is correct. Click Run down at the bottom right-hand corner. Now that we have run the tool, how do we see the results of that tool? There's a couple ways to do this. One is that any of the towns and populated places that we selected from that tool with more than 5,000 people will be highlighted in the map view. This can sometimes be tricky to see. I happen to know that Nook is going to be highlighted, so I'm going to zoom in here to show you that while it is a little tricky to see, the little white dot for Nanook is now yellow, which means it has been highlighted. Another way to find those results is to open up the attribute table for this layer. Go over to the layer in the Layers panel for Populated Places. You will see that the populated places that were selected with more than 5,000 people will be highlighted in our attribute table. If you have an attribute table that has a lot of records, it can be tedious to scroll through. A quick way to see all the data is to go to the left-hand bottom corner and click on the button that says Show All Features. This is a filtering function for the attribute table. If we click on that, we can show selected features instead of showing all features. This will remove everything from the attribute table that was not selected by that tool and just show us the things that we're interested in. To remove the selections from that tool is pretty simple. There's a tool up here called Deselect All Features from this layer. It's a little red or yellow square with a little red square next to it. And if I click on that, it'll just deselect everything so nothing is highlighted anymore. If you're just searching for individual data points and you want to filter them by a particular attribute, the Select by Attribute tool is a really handy way to do this. Let's look at another tool and example that we can use to query some of our QGreenland data. We're going to run a tool to do some layer statistics. Specifically, we're going to run a tool to answer the questions: what is the total number of people in Greenland's populated places, and what is the average size? We can answer all of these questions using one tool. Open the Vector Analysis tools. The tool we want to select is the first one here, called Basic Statistics for Fields. Double-click on that tool. Our input layer at the top here should be populated places. If this does not show up for you, please click and navigate to the populated places and select that layer. The field to calculate statistics on this next input is going to be exactly the same from before, because we're interested in the population attribute of this data layer. We want to know the statistics about population, so the total population and the average population size. Leave the last box as it is. If you run statistics, you have the option of saving your output to a permanent file somewhere on your computer. To do this, click on the box on the right-hand side of this input that has 3 little dots, and this will give you the option to browse a file or folder on your computer to save the output of this tool there. For the sake of this tutorial, I'm going to save it as a temporary file, and I recommend you do the same. Double check that your inputs look correct. Make sure that the population is the field we want to calculate statistics on. Click Run to run the tool. Once I exit out of this tool, I'm going to show you another way to find the results of that tool. You might notice that we have a couple of new panels showing up underneath our processing toolbox. Mine shows up over here on the right-hand side. It provides you a link to the file path which you can actually click on. When you click on it, it's going to open up a new window in your browser that shows you the results of that tool. This is all the statistics on the population attribute for that populated places layer. This mean value gives me the average size of the population for each of those places. It also gives me the sum of the total populations for each of those populated places. There's a whole bunch of other statistics that we could look at for that particular layer and attribute. Overall, this is a helpful tool to get you a sense of the statistics of a particular attribute in a layer really quickly. Let's do another example where we do an analysis of a raster layer using the processing toolbox. The question I would like to answer using the raster layer and tool in our processing toolbox is what is a good estimate of the Greenland ice sheet's volume? The data layer we are going to be using to answer that question is a raster layer called ice thickness, and it has a 150 meter resolution, which is a good estimate of the volume of ice in the Greenland ice sheet. If you open up this set of terrain model layers at the bottom, our ice thickness layers is nested within the bed machine set of layers. Toggle this layer on. To expand it, click the little arrow next to it. You can see that there is a lot to scroll through, but it can give you a sense of what the colors in this color ramp means in terms of its thickness. Since this is a raster layer, we are going to be using one of these tools in the raster tool options to analyze this layer. Go ahead and open up the set of tools under raster analysis. There are quite a few options, and the one that we're going to use is called raster surface volume. Double-click on that and open up the tool. Make sure that the input layer you want here is the ice thickness layer we just toggled on. The second input here is called band number, and there's only one option, so we're going to leave it here as is. This base level here is just asking us basically, where do we want to sum from? If we're going to sum up all of these grid cells of ice thickness, what is the minimum value we want to sum them up from? We're going to leave it at 0 because 0 means 0 thickness. So that's the minimum ice thickness any particular grid cell can have. The method that I'm going to use is to count only above the base level. This means that we're going to sum up everything above 0. If you want, you can click on the little box with these 3 dots and navigate to a place on your computer where you'd like to have these outputs saved. Before clicking Run, make sure to double check all your information and your inputs. Click Run. In this log window, it gives you the outputs for this tool. I prefer to look at it in the browser window. I'm going to close this current window, and just like the statistics report that we got last time with the last tool that we used, I'm going to click on the link that we have been given, and this will open up the window in our browser and show us the results of those tools. In this case, we're given both an area and a value. The volume number here is the one that we're interested in. The downside is that you're given a unit for the area but not for the volume. The area unit is useful because you can then presume that the volume is going to be meters cubed. If you're not given units here, you can also go back to the layers property to see what units for these various layers are. In this session, I showed you 3 simple examples of how to analyze individual data layers in QGreenland using individual tools from the processing toolbox. Now it is your turn to explore the processing toolbox. Afterwards, click on the next session.